Welcome to Reactive Spring Security 5.1 by example. My name is Rob Winch, and I am the project lead for Spring Security. And I just want to take a moment to do a little advertising. The Spring Security team is hiring, so if you guys like Spring Security, you like application security in Spring, I encourage you to apply. I'm sure you could just Google it if you want as well, but there's a bit.ly down at the bottom. So even if you say, well, I don't really know if I can, it doesn't hurt to apply. Go ahead and reach out to us. We'd love to hear from you and hope to see you on the team soon. So that's enough of our infomercial. I want to start talking about our agenda, but before we do our agenda, I do want to get kind of an idea for where you guys are at as an audience so that I can kind of see where I need to focus on. So first of all, quick show of hands. Who here is on Spring Boot these days? Good. It's usually a no-brainer, but you always got to double check. All right, so who here has used Spring Security before? Great show of hands, awesome. Who here is using Spring Webflux? Okay, good show of hands as well. So who here has done reactive programming before? Okay, great. Thank you, that helps me. So today's agenda, what we're going to kind of focus on is taking a tour, applying Spring Security to a reactive application. And along the way, we're going to take a hit at some of the new features in Spring Security 5.1. And the first thing that we'll do is we'll talk about how to do like a custom user. And then we'll talk about how to use the new password support for migrating passwords. We'll also talk about how to set up the sample application to use OAuth using the new reactive bits as well. And then, pending time, we will also extract that into Spring Cloud Gateway so that you can put your authorization logic into a gateway rather than in your own application. All right. And as always, if you guys have any questions, the best time to ask a question is right away. So if you have a question, go ahead and raise your hand. And if I can see your hand, I will call on you. It is kind of hard to see up here, but do keep it up. I will try to call on you. All right, so that is the end of my slides. One thing I do want to say before we go any further, I do ask at the end of the talk if you could fill out the survey, so don't forget to do that. And without further ado, let's go ahead and take a look at our demo. So we have a very simple application here. It's kind of my go-to because it's a really simple domain to follow. It's a messaging application. And the application basically just lists out an inbox, and then we can also go ahead and delete a message. So nothing super exciting there. And then we also have this sign-up link. And in the sign-up link, we can basically add a new user. So new user, and then we'll just give them a new at example.com and type in the password. And then you might say, well, where did that go? So our application is actually broken up into some microservices. So the first microservice is a user service, and we'll see how after we did that, actually it's 8081. So we can see that that new user basically got added into that list. So nothing super exciting there. But the other thing that we want to pay attention to is there's two users that are already there, Rob and Joe. And you'll notice that those passwords look like a bit of gibberish, right? So that's because they're encoded. And then the new password is just plain text. And obviously, you wouldn't even expose your passwords on a real REST service if you're doing things securely. This is somewhat for demo purposes so that we can kind of see what's in the database and how we're going to progressively add stronger passwords to our application throughout. The other microservice that we have is a message service. And all it is kind of displaying our inbox. And then you can also view a particular message, which we saw in the UI. And then the third piece is actually the client. So that's our inbox web application, which is making the REST calls to these two microservices. So nothing super complicated there, but it'll give us enough to establish our, it'll give us enough to add security to it. So now the real question is, can anyone tell me what is insecure about this application? Okay, it's a trick question because there's no security. No security. So let's see how we can at least step it up and add security to our application. And we're going to do that first on the inbox application, which is just that web application. So nothing on our REST endpoints for now, but we'll gradually add things as we go along. So let's take a look and see how we can do that. Oops. So the first thing that we'll do is we'll go back to here, and we're going to open up our POM file. And in here, we need to add some dependencies. And it's actually just going to be Spring Security boot starter, and then the Spring Security test jar, because you always want to have tests, right? Now, for those that are used to Spring Boot, and it sounded like a majority of you are, you'll notice this is the same starter that we have with non-reactive applications. So you might be saying, well, how does that actually work? Well, the reason is just similar to how Spring Web has optional dependencies on reactive bits, Spring Security's support is also optional reactive. And the way that it figures out that it's reactive is that up here, we already have Spring Boot Starter WebFlux. So boot basically sees that you have WebFlux and you have security, and it knows that it must be a reactive web application. All make sense? Okay, great. So now that we've done that, we actually have all that we need for our minimum number of bits to get started. So we'll go ahead and restart our application. And once it restarts, we'll have security applied to it. And the other thing that we also want to do is we want to copy this password, because by default, just as with the non-reactive bits, it's going to automatically generate a password for us. So let's go ahead and take a look at our application. You'll see we get a login page, and we can go ahead and type in user and then the password that we provided. And we're logged in. It was pretty easy. Next thing we can do is we can just log out. There's a logout page. You'll notice if you do a get to /logout, it gives a logout form, and that's so that it can provide the cross-site request forgery token. Who's here familiar with cross-site request forgery? Good show of hands. Okay, we'll skip that. If you're not familiar with it, you could just Google it, but it's a type of attack that you want to protect against. Spring Security does it out of the box for you. So we'll go ahead and log out, and now we've been signed out. Now the other thing that we have actually out of the box is if I do it through a console here, if I do it through this console, I get a 401. So you'll notice this is very obviously different than what happened when I did it through the web browser. It did a redirect to the login page when I wasn't authenticated. And the reason that that is happening is because Spring Security by default will do basic auth and form login, and it determines it using content negotiation. So if this client explicitly said, I do text HTML, not just //, it would actually do the redirect. Now, obviously, that means that we could just do a basic auth, and then we get our page back. Okay? So nothing too surprising there, but it's nice to know that you can do both basic auth and do form-based login in the same application, and it happens right out of the box with Spring Security. Okay, so the next thing that you'll probably want to do with your application is you've added Spring Security, but you're getting this annoying random generated password. And obviously, this is not going to be ideal for most users, because if you restart or if you have multiple instances, you can't really do anything with it. So let's take a look and see how we can customize that password first of all. So the most obvious way, if you've done the non-reactive bits, and probably the easiest way, is to go into your application properties or YAML, and you can type in the password here. Okay? So if I just type in the password, then we're good to go, right? Nothing too surprising, but it's not too exciting, so we're not going to do it that way. Instead, we're going to go ahead and add a new class. So we'll add a new class here. And we'll call it security config. It doesn't really matter what you call it. And we'll go ahead and add our enable WebFlux security annotation. And then we're going to add a password encoder. So We'll do, let's not do that one. Let's do this one. So I have some templates to make it go a little faster. But here you'll see that I'm basically using a username, and I provide the password. And if I start it up with this configuration, it would actually blow up. And the reason for that is Spring Security's password encoding support is by default using what's known as the Delegating password encoder. And it does that because back in the day, it used to be, OK, I have a password, and I'm going to put it in my database. And it's presumed that it's secure because it's in a database, and the database has a username and password. Well, we realized that that wasn't actually true because they do these SQL injection attacks and do a database dump, and the password get exposed to the internet. And then they realized also that everyone reused the same username and password. So if one site got compromised, then you could actually compromise pretty much the entire web. So instead, we decided as security professionals that we should do a little better protecting our users' passwords. And we ran those passwords through a one-way hash. And back in the day, that used to be MD5. And can anyone tell me who thinks MD5 is a great idea? Should we be using MD5? Yeah, you don't want to be using MD5. It's no longer secure. And then, so we decided, OK, it's not secure because there's collisions. It's just not the right algorithm for passwords. So we ran it through SHA. And initially, SHA was deemed to be a good idea. But we had additional advancements. And they realized that because an attacker could just run the passwords through the hash function and then store them in what's known as a rainbow table, they actually were able to crack these passwords too. So rather than doing the work for a specific password that they see and trying to figure out what that is and then doing work again, they'd store all that work and then they'd just look it all up. And all these rainbow tables were available online. And so to get past that, we decided to add salt. And all salt is random bytes that's combined with the password passed in. So the way it worked is you'd have some random bytes that were stored alongside the password, just plain anyone could see them. And then whenever someone logged in, you type in your password. And then to validate it, they take those random bytes, the password that the user typed, run it through the hash function, and see if that matches what was stored. And what that did was it meant now the attackers had to do every set of random bytes combined with every password. And it just became pretty much impossible for them to do these lookup tables because the random bytes were a large number of bytes. Now, the thing is in modern day security, this is still a bad idea. And the reason for that is because SHA is too fast. It's a cryptographic hash function, and it's intentionally fast. But with modern day CPUs and even GPUs, you can perform on the order of billions of hashes a second, billions with a B. And so that means that you don't need to actually store anything. You can just compute it right away. So the modern approaches to storing passwords are using things like bcrypt or scrypt or Argon2. These are intentionally PBKDF2. These are all algorithms that are intentionally resource intensive. And I say resource intensive very deliberately because it's not only the CPU that's going to be bound, but it's also in many cases the memory that's going to be bound. So for example, scrypt has defenses against using GPU because it takes up more memory than most GPUs can actually use. And the other thing that's nice about these functions is they're adaptive. So it's adaptive one-way functions. And the reason why it's adaptive is because as the technology increases, you can actually add more work, a higher work factor to each of these password encoding mechanisms. So what is the point of all this? Why are we even talking about password encoding? Well, the point is that security evolves. And in this particular instance, more importantly, password encoding or storage evolves. And as a framework, Spring Security really can't be changing how it stores passwords all the time. As we said earlier, it's a one-way function. So even when you're using MD5, if you did what was best practice 10 years ago, now you have this application with all these MD5 passwords. How do you migrate your users to a newer password mechanism? And how do you support that concurrently with your new users? So this is what Spring Security added support for in 5.0. It basically looks for a password prefix, and it will delegate to the password encoder. And we'll see that format in just a minute, but you'll notice this password doesn't have that prefix. It doesn't have, it's just password. So this is going to fail if we started it up. But rather than just seeing that, we're just going to take my word for it. It would fail. We're going to see some options that we could do. So one thing we could do instead is we could say with default password encoder. And then instead of doing with username, we just say username. So what this is going to do is it's going to say, that password that you pass into me, I'm going to actually encode it using the default password encoder. And so this will actually be stored correctly. So this is a slight improvement from what we had before, because whatever's stored in memory is actually going to be a hashed password in the most modern way, you know, at that particular time that that code ran. And so that's a step up, but the problem is obviously the passwords, it's hashed into this, it's compiled into the source code. So it's still, this password is still quite vulnerable. So what can we do to make this a little bit better? Well, you could just hash it up front. This is really great for demo purposes, but in the real world, you want to actually hash the password up front. So how can we do that? Well, the easiest way we can do that is we can do Spring Encode Password. So who here is familiar with the Spring command line utility that comes with boot? Anyone? Only a couple of hands. So if you go to the Spring Boot documentation, it'll tell you how to install it. And it's basically a utility for doing things like running a Spring Boot application. It used to be the way that you'd run like a Groovy application, basically the hello world tweet, or the app that fit in a single tweet. You could use the Spring utility to run that. But there's other things into it. And since Spring Boot 2.0, it has this encode password function. And what we're going to do here is we're just going to go ahead and run that. And all I'm doing is sending it to my clipboard. So I just grab that, remove the new line, and then I put it on my clipboard so you don't have to watch me copy paste. And then we'll go ahead and add it. So now we have this bcrypt encoded password, right? And now if someone actually decompiled this source code, it's, obviously it's not ideal that they see this hash, but this hash is a secure mechanism for storing the password, and it takes quite a bit of effort to undo. I mean, it's very, very difficult. And one of the questions that we often get is, it says bcrypt at the very beginning. Is that actually secure? Because it's revealing how the password is being stored. Is that a good thing? Is that a bad thing? Does it matter? And the answer is, in cryptography, in cryptography, it must be secure even if the opponent or the adversary knows what algorithm you used. So this is perfectly fine. And in fact, if we removed bcrypt from the front in there, almost anyone that knows anything about password hashing would know that this is bcrypt anyways, because $2A is kind of a fingerprint for bcrypt. It's the version that bcrypt is using. So there's often telltale signs or fingerprints within the hash already that most adversaries are already going to know. But what does this bcrypt do for us? Why do we actually add it on there? Well, the reason is we have this delegating password encoder. We have this delegating password encoder. And all it does is it basically looks for that prefix. We'll go back to this because it's probably a little easier to see. It looks for this prefix that we saw earlier. And it says, OK, if it starts with bcrypt, then I will validate with the bcrypt password encoder. If it starts with MD5, I will validate with that. If it starts with XYZ, I'll validate with XYZ. So by default, we pre-configure a certain number of password encoders, but you can always customize this. But the difference is that if you encode with this, it's always going to encode with the most modern mechanism at that time. But we can still validate passwords that are basically encoded in any of these formats. So say you made that right choice 10 years ago, you can actually add that prefix to your MD5 and then use this delegating password encoder and then encode in bcrypt going forward. All make sense? Awesome. So we're going to go ahead and move on from here. We've already customized the password. And we're going to go ahead and just see that in action real quick, just to make sure we're still working. And so all I got to do is I can type in. So remember, I used Rob at example.com for that. and then I typed in the password. So it's working as expected. Now, one of the things that we didn't show is that it's actually a little bit broken right now. So if I try to delete this, we talked about the cross-site request forgery token. It's not getting included in the request. And in fact, there's another thing that's broken too. It's this, I'm logged in and I see sign up. I don't see the logged in user. And if we look at our layout, so I'm using Timeleaf here. And all it is just a templating engine if you're not familiar with it. But basically what it amounts to is I'm trying to include the current user's name, so, and that's basically the username. So why is that not working, and why is this current user null? Well, and how do I access the currently logged in user, I guess, more appropriately? So the reason for that is because we're using reactive bits, you don't want anything to subscribe to either the token itself or the authentication, unless you need to use it. So Spring Security is making those available, but our application doesn't see it in the model. And an easy way to get through that is actually just to do a security controller device. And the name is arbitrary, but that annotation controller device is something specific. Anyone familiar with controller device? Who's here? Controller device? OK. So this is basically kind of like a filter. It's like an aspect in that these models will get populated for every request within Spring MVC. And you can narrow it down if you want and stuff, but we're just going to do it for everything. And all it's doing is it's saying, OK, I'm going to resolve the cross-site request forgery token. And then if you look at our forms that we have, we're just using Timeleaf. And then Timeleaf will automatically recognize it and add it for you. So as long as you're resolving it using this mechanism, and the source code's available later on, so if you want to see that, you'll be able to get it from there. And in fact, I can't remember the version, but it's coming out shortly. Timeleaf will do this for you. So that's coming very shortly. And then similar for the current user, Timeleaf will be able to resolve that for you as well. But for now, the easiest way is to just resolve it for it. So we'll go ahead and start our application again. And we'll see that after we log in, we should be able to see the currently logged in user. The sign up button will go away. And then also when we try to delete something, it should just work. So we'll go ahead and do Rob. So if you see at the upper right, it says Rob, and it gives a logout button. And then I'll go ahead and delete this message, and it goes away without the error. So we're able to resolve those pieces. And again, that support is coming built into Timeleaf in the very near future. I'm not sure the exact dates, though. OK, so this gets us a lot further along in our application, but it still leaves a bit to be desired, because if I see this login page, the login page was very handy because no code had to be written from the user's perspective. All we did was add Spring Security. But it doesn't fit with the rest of the application. Now that I fixed that quirk with the currently logged in user, there's no link to the sign up page, right? You'd expect that to be on the login page or any public-facing pages. So how can we add a custom login page that fits our UI and allows us to sign up new users? We're going to take a look at that next. So we're going to open up our security config. And in here, we're going to add the most basic configuration. So you might say, well, where did that come from? If you don't know what the default configuration is, if you didn't do anything, this is it. But if you need to get it, it's actually just on the Java doc of the enable webflux security annotation. So you can just basically copy paste the code that we had from there if you need to know what to do by default. All right, so this is what's happening by default. But because we haven't specified a login page for Spring Security, it's going to render that for you. So if we actually provide one, if we actually provide a login page, very much like the servlet bits, then it'll actually try to render that page instead. It'll redirect to that page. Now, of course, we want to make sure that we grant access to it. So let's say login, And then we have some CSS, so we have to say webjars. That's where all our CSS is. And then we're also going to say users sign up. So these are all the things that we want to make permit all. Okay? So we're just granting access to any user. You don't even have to be logged in. Anyone can see those resources, and then they're able to do that. So we'll go ahead and restart the application. And while that's restarting, let's take a look and see what our login page looks like. I already had that typed up just so that we could move along a little faster. The controller is very obvious. It's just if it goes to the URL login, then do the view login. And then the login HTML page is also very simple. If you've done standard Spring Security, all it is a post to /login. We check for an error parameter, and then we say that invalid username password. We also check out for the logout parameter for a logout success. And then we have a username and a password, and those HTTP parameters must be a post to /login. And again, you need the cross-site request forgery token in this request, but because we're using Timeleaf and we did our controller advice, Timeleaf will automatically see that and populate it for us. So we don't have to do anything additional there. So now let's go ahead and go up to here. And it appears that it didn't start, so we'll go ahead and check that out real quick. Let's see here. What's that? Oh, yes, thank you. Thank you. Yep. So what I'm trying to teach you here is that it's very important that if you do it in the wrong order, things are going to break. And what Spring Security is trying to tell us here is that that basically you cannot. Each of these paths are considered in order. And so because earlier it was like this, path matchers was second. It was saying, okay, the first thing it was checking is it any exchange? So match everything, and then authenticated, right? So if it's any exchange, then you must be authenticated. Well, that means that no additional rules are actually going to apply, right? And so that basically, this error message is saying, you can't have match anything and then another rule because that other rule will never get matched. It's only the first rule that gets applied. So instead, what we need to do is we need to move it up, and then since we moved it up, it will now consider the login, webjars, users, sign up, permit all first, and then any exchange. Make sense? All right, so we'll go ahead and restart that again. Thank you very much there, Josh. Go ahead and start that up. And we get our login page. And now you'll see it looks a lot more like the rest of our application. And if we inspect it, let's inspect this. See it in here. You'll see, it might be hard to see there, so we'll just do this. Gedit. Probably should have make this a little bigger. So what it did was it automatically added that cross-site request forgery token in there. So you can see basically that input was automatically added for us, even though we didn't code it ourselves. And now what we can do is we can go ahead and log in as our user and then log out. And if we log out, we basically see the logout success. If we try to log in with invalid information, we get our username invalid, or username password invalid. Okay, so now we have a reasonably good-looking application. Well, I guess you could argue it's not that great looking because I did the UI and I'm pretty terrible at UI, but it's at least reasonably consistent, right? So now we really want to resolve another big burning issue. I have this user in the security config that is different than the users that are in my system that we already looked at. So we already looked at these users here. It doesn't make sense that I have a separate system for my users. And in fact, almost all the time you're going to want to have your own way of storing your users and retrieving and validating the users. And the reason for that is because you're probably going to have custom properties. So here I have like a first name and a last name on there. So maybe instead of saying hello username, you want to say first name, last name, or just first name, whatever. You might need to access that identifier. And you might say, well, why aren't these properties actually on Spring Security in the first place? Shouldn't Spring Security just have these? And the answer is, well, Spring Security is only interested in its own domain, right? It makes no sense for us to add an ID on there because Spring Security doesn't care about the identifier. It has nothing to do with the authorization logic or authentication that it's trying to perform. And what's more is people might not necessarily agree on these additional properties. For example, someone might want first, last name, someone might want full name. And someone else might want an address, and someone else might want a list of cars that the user owns. And so you can see how this would get very blown out of proportion. And we can't just add all these properties. But it makes sense for your domain to have your domain-specific properties on there. So let's see how we can actually use a custom user detail service, reactive user detail service, with our existing domain. So we're going to go into here, and we're going to add a new class. And we'll call this one service reactive user details service. And we're going to make it a component so it gets picked up automatically. And then we want to make sure we implement reactive. Oops, that's the wrong one. Reactive user detail service. And then we're going to go ahead and implement that method. So all it is given a username, give me a user details. And that user details is stuff like what roles does that user have? What does a password look like for that user, et cetera. All right? So this is pretty easy for us to implement. We actually already have in our application a way of accessing our users. We saw that because in our application, we're seeing the messages and the user information within the messages. So we already have a way of doing that. So let's leverage that API. And most likely, you will probably have that as well. So it doesn't really matter how you do it, but ours is going to be we call it a user service. And then we're going to go ahead and add a constructor. So obviously, that gets auto-wired by Spring automatically because of the single constructor there. And then the next thing that we're going to do is we're going to say, OK, this.users.find by email. And we're going to use a username. So our usernames are going to be our email address, pretty common pattern. And then what we need to do is we want to map it. Let me bring that up to the top so you guys can see. Then we're going to go ahead and map that to a custom user. All right? And so the first step is we need to create our custom user. And then we also need to create a constructor. So this custom user, we want it to actually extend. We want it to extend user. And that's our own domain model, right? So it is a user. And then we also want it to implement user details. OK? So now that we've done that, we can go ahead and auto-generate those methods. And our current user already has a constructor that takes in an existing user. So that basically copies all of our domain logic into this one. But then we also need to implement user details. Now, you could provide any sort of mapping you want for these other properties. Maybe you have them in a database. Maybe they're part of the results of your existing user. Maybe they're in a separate service. It doesn't really matter, but provide some sort of mapping logic. And like any good demo, I've come up with the most complicated way to map that. I have a constant here of role user. But obviously, you can do however you need to. So then we're going to do get username. We're going to just say get email, right? And then all these other ones are flags to determine if this is if the account is expired or if the password is locked or anything like that. So we're just going to just replace all of those with true. All right? So that is our object. Now the thing that's interesting about this is, again, it's a user and a user details. So when we're returning it from this method, we could refer to it as user, because it is a user, and Spring Security can refer to it as user details. That means that we get the best of both worlds. Spring Security has a user details that it can make authorization decisions based on, and we can refer to it as a user object so that we can refer to our custom properties, and yet we are not tied into Spring Security's domain everywhere in our application anytime we make a query or anytime we're trying to display any information. It's just our own domain model, nothing to do with Spring Security whatsoever. Make sense? All right, awesome. So now at this point, we want to actually take advantage of this custom user that we've created. So let's go ahead and update our security controller advice. So we said that that principal that we're returning from that method is both a user details and it is also our own custom user. So let's go ahead and add a way to access it. So this authentication principal mechanism is basically getting from the security context. Spring Security has its own context, has this context, and in there it has an authentication, and that authentication has a principal, right? And we just said the principal type is going to actually be what we were returning. So authentication principal is referring to that type. So that means that we can change this type to just be a user, and then we need to change the return type to match that. Oops. So now we can change the return type to match that. So now this type actually has all our custom properties on it and nothing else. Even though it technically is a user details and a user, we're insulated from that. We don't care that it's user details. We only see our properties. So in our layout, now we could say for the current user, we can just change this to be, instead of name, we can just say first name. So we can access that. So now when we log in, we should see the user's first name instead of their email address. We're accessing custom properties for the currently logged in user. So now that we've done that, we'll go ahead and restart our application. While that's restarting, we'll get a quick drink. Any questions while it's restarting? Okay. And this is another thing that you have to do. If you have added a new user detail service, you have to remove the old one. So we need to remove this old one, because otherwise Spring Security doesn't know which one to use. And it's started, so we'll go ahead and start that up. And now we should also be able to expect to not only log in with Rob and see, oh, yeah, actually this is another thing that we want to make sure that we do. This is the error message that we were talking about earlier. So it's saying there's no password encoder map for the ID null. And the reason for that is, if you remember in our users, the users that we're leveraging don't start with that prefix, right? So the easiest way to do that, if you're in a old system, is to just change your bean here, expose a actual bean to be password and then we're going to return new standard password encoder. And you'll see it's deprecated. And the reason why it's deprecated, it'll say in the Java doc is, yeah, we aren't going to remove this anytime soon, but you shouldn't be using it. So it's kind of a flag to you to say, hey, don't really use this because it's not secure, but we understand that you're kind of stuck in this situation, so we're not going to get rid of it anytime soon. Just don't use it in the future and try to get away from it. So now that we've done that, we should be able to log in with our users. Log in with Rob. Logged in, no problem. And you'll see up in the upper right-hand corner, we are Rob. And then if we log in again, we can log in with Joe. And we're logged in with both users, and we see Joe at the top. All right, so now we're able to refer to custom properties. We're insulated from Spring Security because we're using our own domain object, and we're accessing our own users in our system. But it still leaves us with a little bit to be desired, because our our passwords are not stored in a secure mechanism. So let's see how we can update to support that. All right? So the very first thing we should do is we need to update to use the delegating password encoder. So you can say password, there's this password encoder factories, and it creates a default instance of that. So it has all the standard mappings. This is explicitly providing a bean that is what Spring Security uses by default. So if you aren't using password encoders anywhere else, you don't even need to declare this bean. But we're going to leverage it later on, so we're going to actually place it there. So now that we've done that, we need to actually do a data migration for our users. And so we have this initializer here. And so what I'm using is I'm using embedded Mongo. And so this is how I populate the data each time. Obviously, you won't have the exact same logic here, but the goal is really to prefix all the existing passwords with SHA-256 surrounded by curly braces. So you can imagine in your own system, it's pretty easy to iterate through all your users and prefix it with SHA-256. It'll vary by system, obviously, but that's how we're going to end up doing it. So now we can go ahead and restart our user application. And then we're going to go ahead and restart our inbox. And while that's going, we're going to take a look at our users again. And you can see now our data migration worked. It's prefixed with SHA-256, right? So now, if we go ahead and try to log in, it works just fine with the default password, the default password encoder. So what does this buy us? Well, let's see what happens if we add that password encoder to where we're signing up. So we're going to go ahead and go back to our inbox application. And in there, we're going to go to the user controller. And in here, we're going to add a new variable, password encoder. And I think I might be in the wrong, oh yeah, that's in the user one. Apologies, that's the wrong one. It has to be, there's a user controller for our REST service, but there's also one for our inbox. So the class path does not have Spring Security on it yet for our REST service. So we'll do password encoder. And then we added the constructor parameter. Now the other thing that we're going to do here is we need to say whenever the user signs up, we want to do on success. We'll say u.set password user.get password. And so all we're doing is saying whenever the user signs up, encode the password using our password encoder. And then we're also going to say subscribe on. And I'll explain this in just a second. Subscribe on in Reactive is basically a way of saying which thread to run on. And this is important in this case because password encoding happens to be a blocking operation in the sense that we talked about how it's CPU intensive. It's recommended that it takes about half a second to 1 second to encode your passwords and validate passwords. So if you're using a reactive application, which everyone in here said that, pretty much everyone said they've been doing reactive programming, you're going to be blocking the main thread. So you can't do that. So that means that you actually have to offload how you validate the password onto a separate thread pool. And this is no exception because it's encoding the password. It takes a lot of CPU. We have to delegate to a separate thread pool. Otherwise, we're blocking the dispatcher thread. All right? So that's the easiest way to do it. It's pretty simple. And then now, if we restart our inbox application, we should be able to sign up a new user. And so we signed up that new user, and now we'll just go ahead and take a look at the list of users. And you see that we have not actually added it yet. It did not actually encode. I'm sorry? Oh, thank you. You guys are passing the test. I appreciate that. Encoder.encode. So we'll go ahead and we have to restart 2 applications because otherwise we'll have two of the new users in there.
Scroll up a little bit.
Yes. Yeah. All this source code is going to be available online. So if you're wanting the source code, it's actually already in GitHub. So and I'll make sure you guys can find it. All right. So we'll go ahead and restart the inbox application. And obviously, it's not going to be there anymore, so we have to go through that flow one more time. And we'll do new. So now we've signed up. And you see now our old users start with SHA-256, and the new user starts with bcrypt. Okay? So now new users are able to use the new safer mechanism, and old users are still stuck where they're at. Because remember, it's one way. We can't undo it. So what we can do now is we can say new@example.com, and we can log in as them. All right? So it's pretty nice that we're able to do that for our new users, but what about our old users? Now, this is a new feature in Spring Security 5.1. And the way that we can do that is we've added a new API. So we're going to go ahead and take a look at that. All we have to do for our service that we created earlier is add one more method and implement a new interface. So it's called Reactive User Details Password Service. And as you can imagine, it's just for updating the password. And we can implement that any way that you need to based upon your system. But we're going to say users, find by email, just like we were doing earlier, get the username. And then we're going to map that to a method called this create. And in here, we're going to return mono of user details. And this create method needs to now basically, given our user, it needs to be able to create the actually, we want to do this first. I apologize. First, we want to say do on success. We want to say there we go. Do on success. So this is our own domain type, user.setPassword, and then new password. That's already encoded for us, so we don't need to do anything extra there. And then after that, we want to map that to, we want to flat map that to this.users save. So that way it's saved for next time. And then the next thing that we need to do is we need to hit a wild key there, apparently. The next thing we want to do is, given the user that we just saved, we can reuse our custom user new. And so this is very similar to what we saw with the mapping of find by username. We're just mapping it to that same custom user after we save it. Okay? And then if we restart our inbox application, now if I log in as Rob, it should update the password. If I log in as Joe, it should update his password. So we'll go ahead and log in as Rob first. And now if we look at the results of our users, you'll see that Rob starts it with bcrypt. And we already saw that we can log in with bcrypt because we did that with the new user. If I logged in with Joe, it would also update. Now the other thing that's important is it won't update a user that's already up to date. It already knows if you're using bcrypt, it doesn't need to update again. And that's important because, as we said, it takes half a second to a second for the validation, and then another half a second to a second for the upgrade. So this is a nice way to do it. And now what you could also do is you could say, hey, users, please go ahead and change your password because we're making security improvements, or however your marketing wants to spin that. And that's good because if you're storing it at MD5 and someone got a hold of that password, it's probably not secure anymore. So they probably want to actually change the value of their password as well. But this is more of a business decision versus something that Spring Security can delegate to you. But you could send out an email and say, hey, please change your password because of X, Y, Z. And then that would not only migrate their passwords, but it would also encourage or also store it in a more secure mechanism. Okay, any questions with that? All right. Yes, please.
What was the password stored in before? Was it just plaintext?
So the question was, what was the password stored in before? So if you look at Joe's password is an existing user. It's stored in SHA-256. So what we did was we validated it was valid when they typed in their username password. And once I validated it, I had the original password, and I was able to hash it in the new mechanism and then store it. Because there's no way to actually undo it, but if they typed it and we validated it, we know that it's valid and we can use that to store it again. Does that make sense? Awesome. Yes, please.
Question, is there any, so you mentioned that like as your business model, if you have a whole bunch of 55 passwords, you might want the users to change their password. Is there any way in my application, so you have that update password method, to hook into that and say, if this happens, I want to redirect them to the change password page?
So the question is if you have a whole bunch of MD5 passwords and you want to trigger them to basically update their passwords, is there a way to redirect them to the update password page? And the way that you would do that is you would I'm trying to think of the best way to go about that. Most likely, I would say you'd probably want to do it as a filter because you want to make sure it happens all the time. You don't want to just let them bypass it. Again, it's probably more of a business decision, but you could do like an on authentication success, do some sort of logic because there's a success handler. And then basically, if I need to do something, redirect to that page as well. So if you want it all the time, you'd have to do it as a filter because otherwise they could bounce around. If you only want to try to get them to change it and not force them, then you just do a success handler. Make sense? Cool. All right, yes, please.
So you mentioned that these algorithms are designed specifically to take up resources, and so how do you deal with the SLAs that you might have for authentication versus the expected latency that these things?
Yes, so the question is, these algorithms are intentionally resource intensive, so how do you deal with your SLAs? And that's kind of why you have this balance between security and practicality. Ideally you would have it take 20 seconds, because that's even more secure, but it's just not practical. And it also leads to the fact that if you're storing your passwords in a valid manner, HTTP basic is not a real option because every request is going to be at least half a second. Because that's how long it takes to validate the password. So what you really need to do is exchange credentials for long-term credentials for a short-term credential. And this is not unique to reactive applications. It's across the board because that half a second happens regardless if you're a reactive or non-reactive. So the key is to exchange for a long-term credential for a short-term credential like a session identifier or an OAuth token or insert XYZ. Does that make sense? Right.
This is to stop the person who's trying to hash thousands of them.
Yep. Yeah, and so the comment is the other thing to notice is the one user only has to do a half a second delay, whereas the attacker has to wait for every password they're trying to decipher. And remember also, it's a one way, so the only reason why we can do it in half a second is because we have the password and we can say yes or no. If you don't have the password, this takes much, 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 much longer. Right? Okay, good comment, thank you. All right, we're going to go ahead and try to move along here because we still have the most interesting bits to discuss. I'm going to pick up the pace a little bit by cheating. Let's see. If I can spell master, we will get much further in life. Spelling was never my strong suit. So we're going to go ahead and jump to client credentials. Actually, I am going to do something even crazier. not quite that far, actually. We want to cover quite a bit of material, so we're going to just do jump ahead, and I'll go over the code versus watching us type it. And now the other thing that I need to do is I need to go through here and restart all of the apps that we have. So we'll start with the user one, and then we'll do the message one. We'll do the inbox one, and we're going to restart the gateway too. All right, and we're going to presume that all of those start just fine. That's usually a first mistake of any presentation is presuming anything. But what I'd like to do is show you how we can add resource server support to our application and then use the web client to interact with those resource servers, and then see how we can do single sign-on with OpenID Connect. And then after that, see how we can extract out our resource server logic into the Spring Cloud Gateway. So lots of stuff to cover, obviously, but I think it will be worth our time. So the very first thing that we need to do is go to our application here. And if you're doing any sort of resource server stuff, you want to make sure that you add the right dependencies. So here you'll see I have the resource server and the OAuth2 Jose. So that's the way that we can do tokens. And that's all you needed in terms of dependencies. And then in terms of setup, what you need to do is you want to add a application YAML for the user service. So in here, I have this issuer URI. And that URI is basically the way that we look up the public keys. So if you're not familiar with the issuer URI, there's a convention that allows you to look up the JWKS URI, which exposes the public keys that you're validating against. It's nothing surprising if you've done OAuth support or before, but that's all you need to do in terms of adding resource server support to the application. Spring Boot will recognize that and then configure it for you automatically. So then the next aspect is we want to see how we leverage that. So if we're leveraging that in our inbox, the first thing we need to do is configure a client registration. And the client registration is just a way of saying, this is something, a client that has a key and a secret, and it points to this endpoint. So you can see here I have one provider, and that provider is pointing to the same issuer URI, same metadata that it's discovering. And then we have two different registrations here. One's a keycloak-client, and one of them is just keycloak. And the keycloak-client one is using client credentials, and then the other one is using the default, which happens to be authorization code, and we'll use that for logging into our application and also getting access tokens. So the next aspect is we need to make sure, since we've provided explicit security in this application, we needed to state to Spring Security, hey, I want to opt into OAuth2 client. I want to opt into OAuth2 login. So that's all we're doing here. And Spring Boot is creating some beams that OAuth2 client and OAuth2 login are leveraging from those properties, okay? So now that we've done that, the other aspect that we really want to do is we want to be able to pass along our credentials. So there's a couple pieces that we'll do here. We'll create what's known as a exchange filter function, and it's the OAuth support version of it. And this is basically a way of saying with the web client, which is a reactive way of doing REST template, with the web client, I want to automatically include an authorization token. And if not, you don't have to automatically, but we've explicitly opted into automatic there. Or you can explicitly provide it, and if it's expired, we'll automatically refresh it. So you pass it along, tell it, and then Spring Security will automatically refresh it if it's expired. And it'll do all the logic that you need for that. And it'll make a little more sense when we take a look at how to leverage it. So we're going to take a look at the reactive user detail service. So this reactive user detail service now has a, let's see, that's not what we wanted. We wanted the web client user service. So this is how we're interacting with the user API, right? And we just inject the web client like we normally would. But then we're doing this attributes key cloak client credentials. What is that? Well, all it's doing is it has a static method that says client registration ID equals key cloak client. So that means we want to use that registration information we saw here, key cloak client, to make our request. So Spring Security will see, oh, it's got this issuer URI, so I know how to get the access token using client credentials of a key and a secret provided right there. Make sense? So all it does is say, if the access token exists, then I'll use it. Otherwise, I'm going to look it up using that information. And it does that automatically. If it's expired, it'll go ahead and refresh it. Okay? So that's explicit usage, but you can also do implicit usage. So going back to what we saw earlier in our application code, we also can say set default client registration ID. So for our other endpoint, because we didn't say what sort of access token we wanted to use, we will automatically use that. So in our message endpoint, we don't have anything, nothing changed in here. It's just the same web client usage. We didn't say any attributes or anything like that. Spring Security is just going to do that out of the box. You don't even have to do anything special there. All right? And then the last piece to all this is in our login page, we want to make sure that we have a way to trigger a login, because we can log in via form login now, or we can do a single sign-on. And the single sign-on is just a convention of OAuth2 authorization key cloak. So key cloak is that identifier that we saw in the application YAML earlier as well. All right? So now that we've done that, I can't recall if we restarted everything or not, but I think we did. Yep. So now that we did that, we can actually just go ahead and see that in action. So I go ahead and redirect, and now I'm redirected to KeyCloak. Any OpenID provider will work. KeyCloak just works very nicely locally, so I can just do that. And then I'll log in with Rob. And then I'll type in a password. And I'm single signed in. And the other thing is it's hitting these endpoints here. So if I hit users, I'm not authorized, because that's our endpoint. So you can see that it's automatically getting that access token behind the scenes, and we didn't have to do anything. And it's doing it using something like this. So all I did was I made the call to get the access token using client credentials, and I exported it to a variable. And then we'll go ahead and use that. And now I'm able to get the endpoint. So you can see that the user's endpoint is now using it, and so is the message endpoint. We're just providing the access code version of that token in that endpoint. Does that all make sense to everyone? All right, great. All right, so the last piece that would really be nice is if we didn't need to do the logic in every resource server. Maybe we don't have a hard requirement of having security right at the service itself. Maybe we could just use like a gateway. So we could just undo the security that we had in there and then leverage the gateway. And I just reset that. And so now we're going to go ahead and restart all our applications. And our gateways should be fine already because it didn't really change. So now, if I access the users directly, I actually get the user without any problem because I removed security from it. But what I can do is I can say now, all right, if I access it through the gateway is basically routing traffic from it to the resource server only if it succeeds. So you can see this is not succeeding, but if I do authorization and you have to do bearer, of course. And now basically it's happening there. Now the one thing that's interesting is you might need to do a little bit of custom logic in there. So for our gateway, one of the things that we did was we turn information from the access from the JOT token into a header that's passed along. So here you can see It's probably not extremely obvious what we're doing here, but we're taking something from one of the claims of the JOT and we're injecting it into the header. So that header is basically forwarded onto the user service or the message service. And the reason for that is if you, beforehand, our message service was saying, okay, the currently logged in user, I'm going to use their identifier to figure out what their inbox is. But we need that information even though there's no JOT that we're validating on that side. So here you can see if I just say messages, let's just skip the authorization because we don't care about that. But if I say 8080, 8082, so if I do that, it's going to be a bad request. And the reason is because it's wanting the ID, and then I could just pass in the ID of the user. I'm sorry? Oh, user, thank you. So we're able to see that information. So all that gateway is doing is transforming the JOT into a header that's relayed onto that endpoint, and then you're able to leverage that. And how we added resource server support to the gateway, it's just a standard Spring reactive application. So it's exactly what we saw earlier when we added it to the user endpoints, but we're only doing it in one location. Does that all make sense? All right, great. Well, with that said, we're going to wrap up and leave a couple minutes for questions if anyone has any additional questions. If I don't have time for your question, then I'll be glad to answer it afterwards. So anyone have any questions? Yes, please.
Yeah, the web client stuff is awesome. I'm just curious, in Spring Security 5, is there any integration with REST templates with its open acquisition?
So the question is there any integration with the REST template support? And the answer is no. The reasoning for it is because well, you can manually include the header in there, but we're going forward. Spring Framework is really pushing people to move to web client throughout. So REST template, I wouldn't consider it deprecated, but it's we're really trying we're not really adding much new features in that respect. And it also doesn't have a lot of support for things that we want and need. So there's no way to pass an attribute to it. Like the old REST template support, the only way you could basically communicate the access token was explicitly using, using the APIs that it had of like, here's the header or whatever. Whereas with the web client, you can say, I have this random attribute of client registration ID, and then the filter, the exchange filter function that we registered, can use that information to look up the access token that needs to be added, perform some logic on it, and then basically pass it along. So there's lots of pieces missing from REST template. Good question. We have time for one more question. Yes, in the very back with the hat, please. Oh, the bit.ly link? Yes, sure. So let's see. So let's see, here we go. There we are. All right, well, thank you very much for your guys' attention. And if you guys have any other questions, feel free to come up here and ask, but I'll need to shut down for the next person. Thank you very much.